7.3 Factor Theorem. This is question number 17. This question, and we show that in here x plus 3 is a factor. Then we simplify and we factorize completely. Now that is one root of that one part. I'll tell that, okay, x plus 3 is a factor of this one. Then what is the meaning of that? Meaning that x equal minus 3 is a root. I will tell that x equal minus 3 is a root. What is the meaning of this one? You can tell that x plus 3 is a factor. I will tell that x plus 3 is a factor of this equation. Then what is your conclusion? X equal minus 3 is a root. And I will tell x minus 3 is a root. Then what is your conclusion? X plus 3 is a factor. Now I'll ask, x plus 3 is a factor. Find the root. X plus 3 equals 0, x equal minus 3. Now I will tell x minus 3 is a root. Find the factor. Then follow the method. Minus 3 to other side. Go backward. X plus 3 equals 0. Hence, x plus 3 is a factor. Now, I will ask, x plus 3 is a factor. Then what is the information you can gain? What information you can gain, or what data you can gain from this? It means then x equal minus 3 is a root. What is the meaning of that? This is a curve fx. This fx crosses at x-axis, and this value is minus 3. How do we find root? We make fx equal 0. Then we know this is 0. In other way, when you substitute minus 3 to here, what is the answer should be? How do you find the y value? Now, how do you find the y value here? When you have x equal 3, you have to substitute. If you have a x value, how do you find the y value? We have to substitute x to the equation. Okay, we'll substitute this value to the equation to find y. We know y is 0, but we will show that if minus 3, when x equal minus 3, if minus 3 equal minus 3 cube plus 6 minus 3 square plus 5 times minus 3 equal minus 12. So when you simplify this one, your answer is 0. So now I summarize this one. I will tell that x plus 3 is a factor. Then we know that x equal minus 3 is a root, because x plus 3 equals 0, x equal minus 3 is a root. What is the meaning of this one? When you substitute this one, this y one, the y value has to be 0. in other way. So right now I'll write the summary. F minus 3 is 0. Assume that. Now we'll go backward. If minus 3 makes 0, then what you can tell? X equal minus 3 is a root. Then you can tell x plus 3 is a factor. In the first one we go this direction, and the second one we come back. If x plus 3 is a factor, then x minus a root. When you substitute f minus 3, you will get this answer. In other way, if you substitute some value minus 3, then this has become a then x minus 3. If this is equal to 0, then this has become minus 3. Then this is a root, and then this one is plus 3. Now I'll substitute random value. Okay, I will take this is 3. Instead of x, I'll put f1 here. Then this is going to be 1 cube 6 times 1 square plus 5 1 minus 12. Sorry, for a reason I'm going to change this value. I will take x equal 2. So I'm going to find f2. Then 2 cube plus 6 times 2 square plus 5 2 minus 12. This is 8, and this is 2 square 4 times 6 24, and this is 10 and minus 12. So 24 34 42 minus 4 12, it is 13, not equal to 0. Then what is your conclusion? X equal 2 is not a root. X equal to is not a root. Hence, x minus 2, you want to bring to left, x minus 2 is not a factor. Hence x minus 2 is not a factor. It means if we divided fx by x minus 2, there is a remainder. Now we know that x plus 3 is a factor. It is given actually. Now we want to find the other factors. So I try with x equal to. To here. Then f2, I work out 30. Then earlier I said that x equal to is not a root, hence x plus x minus 2 is not a root. Then I can't write x minus 2 because it's not a root. It's not a factor. Can you give another guess? So when you substitute, that value has to be 0. I'll put x equal 4. Then if 4 equal 4 cube plus c times 4 square plus 5 times 4 minus 12. This is 64. 16 times 6. That is 96. And this is 20 and minus 12. So 64, 96, 106, 116. 116 plus 64. 180 minus 12. 168. Now you see that this is not equal to 0. If it is equal to 0, we can write this is the root. If it is not equal to 0, then F4, it means when you put x equal 4, we will get 168. Then it is not a, then x minus 4, bring it to left side. X minus 4, I bring to this left side. X minus 4 is not a root. Hence, x plus 4 . Sorry, let me correct it as I should. So what we tell, hence, x equal 4 is not a root. X equal 2 is not a root. Now x equal 4 is not a root. Now, hence, x minus 4 is not a factor. Earlier we wrote x minus, hence x minus 2 is not a factor. We'll try another one. X equal 1. Then f1 equal 1 cube plus 6 times 1 plus 5 times 1 equal minus 12. 1 plus 6 plus 5 minus 12. What is the answer? 12 minus 12 equals 0. That's a good one. When you substitute that x equal 1, y value make it 0. It's a root then. Earlier when you substitute x equal 4, it will give something else. I can't remember now. It is 30 or 100 and something. So if you get a value to y value, it's not a root. But now, yes, it makes 0. It's a root then. Then you can write x equal 1 is a root. Hence, which one is factor? Not x. Hence, not x plus 1 is a factor. This is wrong. Hence, x minus 1. Bring this one to left side. X minus 1 equals 0 form. Hence, x minus 1 is a factor. Now, this is x minus 1. Now you found out the second factor. Now, we can try another number and work out the third factor. So, it is a trial and error then. You are guessing a number x equal 3. It works. It makes f3 equals 0. You put x equal 2. Now, f2 not equal to 0. Doesn't work. It doesn't work. And I'll write here. You put x equal 3, right? Then f3 is 0. Yeah, it works. Now, when you put x equal 2, If 2 is not equal to 0, then it doesn't work. And you put x equal 4, then if 4 equal not equal to 0, it doesn't work. And x equal 1, when you put f1 equal to 0, then it works. Then x minus 1 is a factor. Then likewise you have to do to find other one is trial and error. X equal 3, or we put 1, 4, 2, 3. So another values 1.5. Decimals could be sometime, right? Or x equal minus 1. Anything could be. But I know the other one is x equal minus 4. Because already in, now this is number 17, some we discussed earlier in 7b. What are the bracket of this one? X minus 1 and then x plus 4. That's why I told x minus should be the other answer. Now I'll give this sum to you. Right? We'll work together. Okay. Find the roots or factorize this one. Now, how do you factorize this? Now you want to find a value. When you put this value, let's say p, when you put this value, when x equal p, this has to be make equal to 0. When you put this value, this expression has to be equal to 0. Now, we have no choice, we have to do this one. I will take x equal 0 first. When I put f0, 3 times 0, 14, 0, basically everything becomes 0 and minus 4 not equal to 0. Then x equal 0 is not a root. Not a root. Hence x minus 0 is not a factor. Now we'll try another one. X equal 1. Then f1, 3 times 1 cube minus 4 1 square minus 47 minus 40. And when you simplify, I can say that this is not equal to 0. Then x equal 1 is not a root. Hence, x minus 1 is not a factor. We have no choice. We have to do. If we have to solve this one, this is the only way. Now x equal, usually we have, usually we should check 0, then plus 1, minus 1, plus 2, minus 2, plus 3, minus 3. Within this range, usually in exam, you will get a question, not the extremes, right? I will check x equals 0, I 1, then x equal minus 1. So f minus 1 times 3 equal 3 minus 1 cube minus 14 times minus 1, 47 minus 1 minus 14, not equal to 0. Not equal to 0. Hence, what is the conclusion? X equal minus 1 is not a root. Hence, x plus 1 is not a Yeah, x equal minus x plus 1 is not a factor. This is a sum. So likewise, you have 1.5 hours. You have to try whole 1.5 hours. You don't have a time to work out any other question in the paper. So because of that, they will give, you have to still practice, they will give kind of a good number. I mean, usually if they ask like this, 1 or minus 1 or 2 or minus 2, within that range. Since I worked this on this sum earlier, now I'm going to check x equals 7. This is extreme value. You will not get this kind of difficult one. So then if 7 is 3 times 7, 14 times 7 square minus 14 times 7 and minus 14. This is equal to 0. Then x equals 7 is a root. Hence, x minus 7 is a factor. Finally, we trial and error, we found out one. So this is x minus 7 is a root. And now we have to, this is a cubic equation. We may have two or may have not. Now we have to find the other two as well. I know there are three. So there are very complicated, they are complicated ones. So I will tell the answer. One is easy. When you put x equal minus 2, you will get f minus 2 equal 0. Another one is x equal 1, then x equal minus 2. Then what is the conclusion? X plus 2 is a root. Sorry, factor. X minus 2 is a root and x plus 2 is a factor. Also I know other one is x equal minus 1/3. Then f equal minus 1/3, then f minus 1/3 is 0. Hence x minus 1/3 is a root, right? Then x plus 1/3 is a factor. X plus 1/3 is a factor. Now I have to come with you to the exam to tell those two numbers. So how I'm going to avoid that part. We have no choice, right? We have to find first one. So that is our practice. And when you know first one, what is fx mean? I will rewrite this one. 3x cubed 14x square minus 47x minus 14. Right? You know that x minus 7 is a factor. You want to find the other ones. So cross multiply down. So you have to divide this expression by x minus 7. Then you have to do long division. Minus 14x square 47x minus 14. So when you do long division, you can work out. Okay, well, let's work out this one. 3x cubed minus 14x square minus 47x minus 14. So this is going to be 3x square, then this is 3x cube minus 21x square. 3 times, so this is minus, this is going to be 7x square minus 47x. Minus minus become plus. Then I'll bring this one down. This is going to be plus 7x. Then 7x times this is going to be 7x square. This is 49x. And you want to minus. Then this is going to be 2x. And bring this one down. Then this is going to be plus 2. So 2 times x, 2x. 2 times 7 minus 14, 0. Now we found out x minus 7. What is the quotient? 3x square plus 7x plus 2. Now we have to factorize. Now quadratic equation. Now this is a cubic equation. You find a factor by substituting a value which is minus 7, x equals 7, and x minus become a factor, and you divide it and you found the other expression. Now you bring quadratic cubic one, you break into a linear and a quadratic. Now you know how to find how to factorize the quadratic equation. Then x minus 7, the other factors is going to be 3x plus 1 and x plus 2. You can factorize this one. Now my question is, how did you, if I ask you to factorize this one, how do you do? First of all, you have to substitute some values, x equal 1, x equal 2, x equal 3. Don't try to, they don't give usual decimals or fractions, right? And when you substitute, let's say x equal p, that if p is become 0, then what you can tell? X minus p is when you substitute x equal p, if p equals 0, then you can tell that xp is a root. Then x minus p is a factor. Likewise, you want to find one factor. So we found out x minus 7, and then divide this polynomial by x minus 7, and then bring it into a quadratic. And you know how to make quadratic. Assume now you have a cube 4x4, 3x cube minus 4x square minus 47x minus 14. Now this is the power is 4. Now you don't know how to factorize power 4. Then you want to do the same stuff again 2 times. You want to get x equal 1, and you want to trial and error, and assume that you get x equal 2 is a factor. X equal 2 make, this is let's say fx, okay, gx, g2 make 0. Then what is your conclusion? X minus 2 is a factor. Then you are writing x minus 2 times, you have to divide this one and get the x cubic equation. Then you have to rewrite like this, or this is another x cube like this and hx, and you have to separately. Now another question is look like, again you have to do trial and error x equal 4 or something, and then you break this cubic into a linear and quadratic, and then you have to give and fix this, insert it. So this is a, in the long run, if you can't understand this area, that's fine. Still we will discuss again with the time. Now when you look at the factor theorem, you can see now in this book, if p equals 0, if then x minus p is a factor of fx. So I will write from left to right. If p equals 0, yeah, if p equals 0, okay, you can write another one. When x equal p, if p equals 0, then x minus p, I am writing this one in the book, is a factor of fx. So in other way, if x minus p is a factor, that the book says, the second version, second statement, factor of fx, then what you can tell, if p equal 0. So I write from left to right. If x minus p is a factor, then if p equals 0. It is in this same statement. When x equals p, it means if p equals 0, then x minus p is a factor. Then if you make this is 0, then x minus p is a factor of fx. In other way, if x minus p factor of fx, then can you see that f then one? If this one, then when you come to this side, this will become if, and this is then. If xp minus p is a factor, then fp equals 0. So this is the factor theorem. We already discussed in the example now, and if x equal to, when x equal to, if f2 equals 0, then x minus 2 is a factor of fx. Then if x minus 2 is a factor of fx, if then f 2 equals 0, then x equal to is a root. It will be more clear when you start working the sums.